Up until now, we have been using a special 16-byte RAM in order to illustrate concepts in pure binary. We cannot continue like this because eventually it becomes too complex. A large part of the skill that you need as a programmer is the ability to visualize concepts more and more abstractly. So because of that, we are going to change how we look at our 16-byte RAM. Let's imagine the string of text ABC123 with a null termination byte at the end. So here's how that looks in our 16-byte RAM. Let's just say null. Okay. Instead of visualizing RAM like this, like you've been used to, now we're going to change that so that you can visualize RAM like this. And by the way, this right here, that makes it easier to read. This right here just means the null termination character. So when you see this, understand that it means the null termination character, which is a byte of all zeros, which terminates a string of text. So the way that you would read this line of text is that at memory position 8, first you have the lowercase a, then the lowercase b, then c, then the 1, then the 2, then the 3, and finally a null termination character. Now notice that this ellipses at the end of our string of text ABC123 indicates that there's more data that might follow in RAM. We just don't know what that data is, and we don't need to worry about that. With this, we are saying the exact same thing as this, but in a more compact way. So let me make sure that you understand this. So what we're doing is we're saying at this location in memory, we have an A, then a B, then a C, and so on. And what we are doing is we are enclosing every byte, every character in this case, in brackets just to further separate them. You should be able to look at any of those blocks contained within brackets and realize that there is a single byte, 8 bits of data inside that block. And you should be able to understand that this is going to be the byte that corresponds to the lowercase a, and so on. From prior lessons, you should also know what binary sequence is contained within each byte. You should understand that the memory address 8, in this case, corresponds to the exact memory location where the A is stored. And that this memory address, for example, 9, would correspond to where the B is stored, and so on. So visualizing memory like this allows you to observe interesting details about the data. For example, you will notice that it is easy to see how many bytes a string of text represents. You can count out the number of characters and the null character and see exactly how many bytes are stored in memory. So for example, take a look at this string of text which we are storing at this position. Now of course this string of text is going to be, and at the very end we have of course the null termination character, which we're representing like this. So here it becomes easier to see how many bytes there are because you just simply look at each block, 1, 2, 3, 4, 5, and so on. And it's easier than the other layout that I showed you where every single byte is described. And you should be able to understand that this is the same thing as when I listed out the RAM like this. It's just a more compact way to illustrate it. So you can still see that every character resides at its own byte, including the space character and including the null termination character. You should still be able to understand the different binary sequence roughly in each byte, although it's perfectly fine if you can't convert this to exactly what it would be in binary and this and so on. You understand what it is and you roughly understand what the binary sequence would look like, and that's more than enough. So this is the method that we're going to be using from now on in order to visualize RAM. And this will make the future lessons much easier to understand.